4.3 is to prove triangles are congruent by SSS. That stands for side, side, side. In 4.4, we're going to prove they're congruent by side angle side combination and hypotenuse leg. That'll make sense to you after we go through the lesson. Our objective for 4.3, use side lengths to prove triangles are congruent. So before we said triangles, put the food away please. Before we said triangles, to say triangles are congruent, what did we have to have last time we talked about this? We had to have what? To say triangles were congruent. We had to have all three sides congruent and all three angles congruent, right? 6 parts. Side, side, side congruence theorem says that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. So you don't need to show anything about angles being congruent. As long as the 3 sides of both triangles are congruent, the corresponding 3 sides, then you can say that the triangles are congruent. In this case, ABC, AB corresponds with FE. They both have one tick mark. And BC corresponds with EG and so on. ABC is congruent to FEG by side, side, side. Remember, the corresponding points have to match up. You couldn't, you couldn't say ABC is congruent to GFE because the A and the G don't go together. The A is between the sides with 1 and 3 tick marks. The G is between the side with 2 and 3 tick marks, so they don't match up. FEG is how they correspond. That's what that's talking about. Order matters. So now we're going to decide if the congruent statement is true and explain our reasoning. IHG congruent to JHK. Well, let's look at that. IHG. So let's look at IH. IH has 2 marks on it. That would correspond to JH. JH is unmarked, right? We could put it, it's congruent to itself. But IH and JH in the 2 triangles do not correspond. So we cannot say this is not true. It's false. Because the triangles don't, the sides don't correspond as they're named. How could I name this triangle to say a congruence? How could we name it and make a congruent statement?
IJH is congruent to JKH.
IJH, JKH?
Yeah.
Okay. IJ corresponds with the IJ and JK are congruent, but then if we go KH and IJH would be this one with 3 corresponds with KH has 2. So the order wasn't correct. Yes, Evan.
IHJ and KHJ.
Yes, you could do it that way. Okay, he said I, triangle, I, H, J. So we go on around it like this, is congruent to triangle KHJ. Yes, those two are congruent by side, side, side. Let's take a look at this second one. LPS, congruent to PLN. LPS, congruent to PLN. Is that true? Logan Liffick, what do you think? She says no. I mean, I think that it's yes. Evan and Abby. Okay. Well, what do you think, Abby? How you think it's true? Okay. You're right, because we've got LPS. So L is the triangle with the side that is shared, so it's congruent to itself. We can put 3 tick marks on it. So we've got LPS. That's the three-sided, 3 tick mark side, 1 tick mark side, and then it continues on up to L. So that's the 2 tick marks. So it goes 3, 1, 2. Now let's look at PLN. PL is 1 tick mark, and NP is 2 tick marks. So that goes 3, 1, 2 as well. So yes, that is true. The next one, triangle ACE is congruent to triangle BDF. ACE congruent to BDF. What do you think? What do you think, Kennedy?
I think it's false.
Yeah, it is false. You look at AC, A to C is 1 tick mark, and B to F is 2 tick marks. You can stop right there. The sides don't match up. Now we could say, similar to like number 1, we could show that these triangles are congruent, naming it in the correct order, but as named, these are not. This is false. STV and UTV. STV and UTV. Aaron. It is true. ST has 1 tick mark. UT has 1 tick mark. TV is a shared segment in both, so it's congruent to itself. And then the VS and the VU has 2. So that would be true. And we would say true by, anytime you say it's true, you should say true by, in this case, side, side, side is our reason. Everybody get the idea about side, side, side congruence. All right. Show triangles are congruent in a coordinate plane. So they give us some vertices. We're supposed to graph them and show they're congruent. All right. So how this would work is after you graph them, we would count we'd figure out the distances of the sides. So each box is 2. You got to be careful on these graphs. You got to look at the scale. The scale here is each box is not 1, but it is 2. So a box and a half would be 3. So we could label KJ with 3. And likewise, RS is a box and a half. So it would be 3. And then LJ is 3 boxes, so that's 6. TR is 3 boxes, so 3 times 2 would be 6. Right? And they're right triangles. We could do Pythagorean theorem to determine the last side. You know, we could do 3 squared plus 6 squared equals x squared. So that would be 9 plus 36 equals 45. All right. 45 is factored into 9 times 5. So when I do the square root of that, we can bring the 9 out as a 3. Square root of 45 would be, we bring the 9 out as a 3 and leave the 5 under, so it would be 3 radical 5. That's how they got their 3 radical 5 with Pythagorean theorem. So that's 3 radical 5. So to show they are congruent, are they congruent? They aren't oriented the same way, but they do have the same side lengths, right? 3, 6, 3 radical 5 in both. Somebody, let's name it correctly. Somebody name the congruence here. Triangle. Let's name. Let's say triangle J. Let's do JKL is congruent to. How would I name my second triangle if I name this one JKL? How would my Jacob?
RST.
Yes, RST corresponds to JKL. JK is 3 long, RS is 3 long. KL is 3 radical 5, ST is 3 radical 5. So on. So these two are congruent by side, side, side. Questions? Proof. All right, we'll do a lot of proof using these congruent shortcuts. So we've got our given and proof. Let's mark our given. It's already marked, but let's mark them again. AB is congruent to CD. We'll give those one tick mark. BC, congruent to DA. So what do you think I'm going to start my proof out with? How about the given statements? The given statements, we would have, step 1, I would have AB congruent to CD and BC congruent to DA, and that's by given. All right, where am I going with this? What else do I want to say is congruent in these triangles? What else is congruent? We've got 2 parts congruent. We need 3 parts congruent to do side, side, side. Kennedy.
AC.
Yes. Always look for lines that, if it's shared by the triangles, then it's congruent to itself. So we could say AC congruent to AC. And that's step 2. So we have AC congruent to AC. And that's, what would be my reason for that? Something congruent to itself. What do we call that? Which property is that? Yes.
Reflexive.
Yes, that would be reflexive. Now, do I have enough to say the triangles are congruent? What do you think, Seth? Do I have enough? Yeah, we do. We've got 3 sides matching up that are congruent. So, my last step would be triangle ABC is congruent to triangle CDA, and that's by side, side, side. Questions on the proof? All right? Let's do another one. So in this one, we'll mark our givens. Let's see, we've got Wx is congruent to xy. So that's step one. We would use that as our given. Wx is congruent to yx. That's given. And z is the midpoint of wy. So if z is the midpoint of wy would be our given. From that statement, from z is the midpoint of wy, what can I say? What does the midpoint tell us about the segment wy? What do you think, Seth? If z is the midpoint of wy, what do we know? Yeah.
WC is congruent to YZ.
Yeah, I already marked it. Okay, I did that automatically because I'm so used to it. Anytime there's a midpoint, it divides the segment in half. So we would say WZ is congruent to ZY. By definition of midpoint. That's what the midpoint does for us. What do we want to say by reflexive property? What do you think, Gage? What would I say by reflexive property? We're trying to show those two triangles are congruent. We've got two parts congruent. What would the third part be? Evan?
XZ is congruent to itself.
Yeah, the shared side. You always want to look for shared sides. It's got a shared side, so that's congruent to itself. XZ congruent to XZ. That's reflexive. And now, what our last step is always going to be what we had to prove. And we've shown by side, side, side. I got three sides marked congruent. We've shown that triangle WXZ is congruent to triangle YXZ. Questions? Okay. Take a break. 4-4. Prove triangles are congruent by side, angle, side, and hypotenuse, leg. These are, again, a couple more shortcuts. Rather than showing all three sides and all three angles are congruent, if I use a side, angle, side combination or a hypotenuse, leg combination, I can say triangles are congruent. So use the diagram to name, first of all, with side, angle, side, that means that the angle is included between the two sides. To be included means if I've got two sides, this angle right here is included between those two sides. Then you'll add a third side and you make a triangle, but the included angle is the one between the two sides. If I've got these two sides marked, this angle would not be included between the two sides, and this angle is not included between the sides. But the angle that touches both sides is the included angle. So in the diagram, name the included angle between the given pair of sides. Logan Calloway. What angle is included between AB and BC? Name it with three letters. The angle included between AB AB and BC. What's the angle included between them?
BD.
Angle. All right, and the angle included between them would be ABC, that angle. So that would be angle ABC. I've got to name it with 3 letters because of that line. That line BD divides it. There's 3 possible angles at B. So I can't just call it angle B. I've got to call it angle ABC. Number 2. BC and CD. What angle is included between BC and CD? Brandon.
BCD.
Yes, angle BCD. Or we could just, since there's just one possible angle there, we could call it angle C. But we'll go with BCD. Name the angle between AB and BD. Kayla.
ABD.
ABD. Good. Angle ABD. Don't forget your angle symbol in front of your angle when you write the angle. Number 4. BD and DA. BD and DA. Angle between BD and DA. Eric. Speak up. Angle BDA. Right. Angle BDA. DA and AB. Abby, which angle is included? BAD. Angle BAD is correct. All right, side CD and DB. Let's see. Taylor, which side is included between those? I mean, not which side, sorry, which angle? BD and CD. What angle is included between them? Say again? DBC would be this angle. Is that included between the 2 angles? The vertex has to be the middle letter. Carly, help her out. What's that? No, I can't start with D. That's my vertex. It has to be the middle letter. Evan. CDB. Right. This angle, CDB, is the included angle. You guys knew which angle it was, but you got to name it correctly. The vertex, in other words, where the angle is, has to be the middle letter. So I'd call this angle CDB. D is the middle letter. That's that angle. All right, any questions there? All right. So now, in a right triangle, the sides adjacent to the right angle are called the legs, and the side opposite the right angle is called the hypotenuse. So if it touches the right angle, it's a leg. The side opposite the longest side of a right triangle is the hypotenuse. We need to know that terminology to do hypotenuse leg. So the hypotenuse leg congruence theorem says if the hypotenuse and a leg, it doesn't matter which one, if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and a leg of a second triangle, right triangle, the 2 triangles are congruent. So here I only have to, well, we know one part, the right angles are the same. Then I just need to show that 2 other parts, the hypotenuse and the leg, are the same. So rather than all 6, Again, it's a shortcut. I just need to show the hypotenuse and the leg are congruent in a right triangle. This is what it looks like. Well, here we have, well, we could do side, side, side here, but if we wanted to do, we could also do this hypotenuse leg. AC is congruent to DE, and then pick either of the legs. BC is congruent to EF. So we could say these triangles are congruent by hypotenuse leg. Let's mark it up. So if we marked it, we would have, so we have the right angle. I can only use hypotenuse leg when there's a right angle. And so we've got the hypotenuse is congruent. And let's take these legs. These two legs, that leg and that leg are congruent. So they're congruent by hypotenuse leg. All right, any questions? Okay. Then the side angle side congruence postulate said, if two sides and an included angle of one triangle are congruent to two sides and an included angle of the second triangle, that's why we did that exercise identifying the included angle. If that we have those congruences, the two triangles are congruent. This is what an example of side angle side would look like. We have AB congruent to EF. We have B, looks like C, BC is congruent to DE. And this angle, angle B, is congruent to angle E. So there I have two sides and included angle congruent. So if I were to name this triangle congruence, I could call it, let's see how which letter he started with. Started with ABC. Started with A. So A matches up with F. B matches up with E. I can tell they match up because from A to B there's one tick mark. From F to E there's one tick mark. So I know those are the sides that match up. E is the included angle. And B is the included angle. So those are both second. That's side angle side congruence. Any questions on those two? Let's do some examples then. So if we have enough information to say the triangles are congruent. So can we say ABC is congruent to DEF? And if so, why? What do you think, Tommy? Not sure? Okay. Anybody? Is ABC, so we've got ABC congruent to DF. Kennedy.
I think they are congruent because of side angle side.
Yes. If you mark the congruent things, we've got this side congruent to that side, this angle congruent to that angle, and this side congruent to that. So yes, we could say they are congruent by, so it would be yes, and it would be by side angle side. Number two, what do you think? Are they congruent? And if so, which one? Evan, you're shaking your head. What do you think?
Yes.
What would be your reason?
Side angle.
Well, you can't use side angle. The right triangles, that should clue you in on, if it's a right triangle, then that's a big clue. Eric? Right, hypotenuse leg. We've got, so in the two triangles, we've got the right angle. So I know it's a candidate for a hypotenuse leg. And then the hypotenuse are marked congruent. MN and OR are marked congruent. And then they share the leg in O, so it's congruent to itself. So there's our hypotenuse leg. So we could say the triangles are congruent by hypotenuse leg. What about number three? On number three, do we have enough to say the triangles are congruent? Let's look at our congruences. We've got AD and DC are congruent. Those are both in the same triangle. We've got these angles congruent. D and B are marked congruent. We have a shared side in the middle. It's congruent to itself. Do we have enough to say the triangles are congruent? You're shaking your head, Jacob.
No. Because
No.
the angles are even. Or the sides are even.
Yeah, we just have an angle and a side common to both. We don't have anything else. There's not enough in the top ABC marked congruent. So this would be no. We couldn't say they are congruent. All right, any questions? Everybody get the idea? Let's see what we've got next. We've got a proof. Okay, so we've got OM perpendicular to LN. That's marked. And then ML. You always want to mark your things that you're givens in your picture. So ML is congruent to MN. We've got to prove that OML is congruent to OMN. All right. So this 90 was, it's in both triangles. It's 90. So we've got our first step, OM perpendicular to LN. Then step 2, read the reason. It says, if two angles are perpendicular, they form 4 right angles. So what do you think I would want? This is kind of like a formality here. What do I want to say? It's not what we're given here. This isn't a given, right? This is, I'm saying, because I know these are perpendicular, what can I say about those angles? And the reason is, if two angles are perpendicular, they form 4 right angles. So what would we say? What do you think would match up with that as a statement? What statement would we have that as a reason for? We haven't seen this before, so I'll go ahead and tell you. We would say angle OML and angle OMN are right angles. They're right angles. OML and OMN are right angles. What do we know about all right angles? They are what to each other? All right angles are, they both equal 90, so they are right. They're congruent. That's our next step. The right angle congruence theorem says that. If you were having to provide that reason, rather than remember that that's the name, the right angle congruence theorem, you could just write all right angles are congruent. It's the idea I want you to know, not necessarily the name. But for that, yes, we would say our next step here would be angle OML is congruent to angle OMN. How do we know that ML is congruent to MN? ML congruent to MN. We marked it already. How do we know? How did we know that? It was one of our givens. Don't forget about your givens. That was given. That was one of our givens. How do we know that OM is congruent to itself? Jacob?
Reflexive.
Yep, anytime something's congruent to itself, it's reflexive. So that step is reflexive. So let's mark that. Now, how could I say the triangle's congruent? Yeah.
Right angle congruence theorem.
No, that's just angles. We're saying triangles are congruent. Kennedy.
Side angle side.
Yes, it's side angle side. Even though it's a right triangle, we couldn't use hypotenuse leg here because the hypotenuses LO and ON aren't marked. We don't know anything about the hypotenuse, but we do have a side angle side included angle side combination in both triangles. So we would say these triangles are congruent by side angle side. Questions? Okay. There's the work. Let's do this proof. B is a midpoint of AE. B is a midpoint of CD. And we've got to prove the triangle ABD is congruent to triangle EBC. So, B is a midpoint of AE. That is given. What do we know by definition of midpoint? If B is a midpoint of AE, Logan Calloway. Yes, and we want to mark the picture when we say that. So AB is congruent to BE. AB is congruent to BE, and that's by definition of midpoint. B is a midpoint of CD. How do we know that, Seth? It's given. So then what do we know by definition of midpoint? Seth Clyburn? Yes. CB is congruent to DB. We mark our figure. All right. Now it says ABD. Let's mark that one. ABD is congruent to EBC. How do I know those two angles are congruent? They're across from each other, formed by lines. How do I know they're congruent? Which kind of angles are they? Kennedy? Yes, VA, vertical angles. So, how do we know the triangles are congruent? Which shortcut? We've got side, 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 side angle side, hypotenuse leg. Which one is this? Abby? Yep, we've got two sides and an included angle. Yes, so that would be side angle side. Questions? All right. There wasn't a hypotenuse leg example in the proofs. I'll just put that up on the board again just to show you what that would look like. Okay.